Hi and welcome to the 6th year higher level maths revision video. In this video we're going to look at revision worksheet 11, which was a section B question on trigonometry. So the question is, the weekly revenue produced by a company manufacturing air conditioning units is seasonal. The revenue in euro can be approximated by the function R of t, which is revenue being a function of time, is equal to 22,500 cos of pi over 26t plus 37,500, where t is greater than or equal to 0. It says t is the number of weeks measured from the beginning of July. Okay, so that will be important. So t is the number of weeks measured from the beginning of July. And the angle is in radian. So now to put our calculators in radian mode. So revenue is the money we get from sales. So they're saying that that's seasonal. So basically, they'll sell more during the summer than they do during the winter, which makes a lot of sense. So it's not like they sell the same all the time. It's going to be quite changing the whole time. So this is where it's going to be represented by a cos function. So the first part of this question says, find the approximate revenue produced 20 weeks after the beginning of the July. Give your answer correct to the nearest euro. So we're actually going to do R of 20. Now remember that R of t is a function. It is not R multiplied by t. So all we're being told to do here is to sub in, instead of t, my 20. So pi over 26 by 20 plus 37,500. Again, just double check that your calculator is in radian mode. And we end up with 20,658.50817 . It said correct to the nearest euro. So that is going to be 20,659 because we're rounding up. So part B says, find the two values of t within the first 52 weeks where the revenue is approximately 26,250. So they've given me the revenue this time. So I'm going to set up that equation. So 22,500 cos of pi over 26t plus 37,500, and that's going to equal to 26,250. So I'm trying to get cos on its own. So the first thing I'm going to do is I'm going to take away 37,500 from both sides. So when I do that, 26t, I end up with minus 11,250. To get cos on its own, I'm going to divide by 22,500, which gives me minus a half on the right hand side. So cos of pi over 26t is equal to minus a half. Now you can work with it like that, but I usually prefer to change it to something a little bit easier. So I'm going to change the pi over 26t to an x to simplify this a little bit. So I'm basically trying to solve for two answers when cos of x equal to minus half. So that's a much simpler question that I'm being asked. Do you remember we're in radians? So here's my unit circle that I'm going to work through. I have 4 quadrants. Cos is positive, all are positive. Sine is positive and tan is positive. We're working where cos is negative, which is quadrant 2 and quadrant 3. And we want that little reference angle. So A is the reference angle, and that will always be acute, and that means the answer will always be positive for cos. So cos of A equals a half, and that gives us A is equal to pi over 3 because I'm working in radians, but in terms of degrees, that's 60 degrees. So I'll just keep that so we can make sense of it as we're going through. Let's make sense of our answer. So let's work in quadrant 2 first. So the x would be 180 degrees. Take away that 60 degrees, which would have given me 120. I'm not working in degrees, I'm working in radians. So instead of 180 degrees, I have pi. Take away 60 degrees, which is pi over 3, which gives me 2 pi over 3. If we were then in quadrant 3 for our second answer, x in this case would be 180 degrees plus 60, which is 240 degrees. X in this case for radians will be pi plus pi over 3, which will give me 4 pi over 3. We didn't have x. Remember that x replaced that pi over 26t. So what I have now is, well, pi over 26t is equal to 2 pi over 3. I'm going to cancel the pi's from both sides, multiply by the two denominators. I get 3t is equal to 2 by 26, which is 52. So t is equal to 52 over 3, which is my first answer. And for quadrant 3, I have pi over 26t is equal to 4 pi over 3. Again, I'm going to cancel the pi's on both sides, multiply by the denominators. 3t on this side, 4 times 26 is 104. So my final answer is t is equal to 104 over 3. So this is a very common type of question where we have something that looks very complicated, but we just need to break it down and bring it back to a much simpler question. Usually we have more than two answers, so we need to add in rotations, but here they only wanted us to have our two values of time t. So part C is asking us to find r dash of t, which is the first derivative of the revenue function we've been given at the start. So in order to work with any kind of differentiation, go to page 25 of your log tables. We're working with a cos function. So we're working with this line here. So when I differentiate cos, it goes to minus sine. Just be aware that when we're dealing with cos or sine or tan functions, we will usually have the chain rule to work with as well. The reason we're going to use the chain rule here is because the formula or the instruction we're given in our log table is cos of x goes to minus sine of x. But we have a piece in front of, not x in this case, but t. And the chain rule will allow us to work with that. So let's work through this question. So r dash t. So the first thing that tends to throw students is the coefficients. What do you do with them? And the answer is nothing. They just sit there. Ignore them for a minute. So our cos goes to minus sine and the angle stays the same. So pi over 26t. But because of this pi over 26, what we're going to do is we're going to multiply by the derivative of the inner function, which basically means we're going to multiply this whole thing by the coefficient of the angle. So we're multiplying the whole thing by pi over 26. So we're probably more likely or more used to seeing it like cos of 3x. So cos goes to minus sine of 3x, but then we multiply the whole thing by a 3. So just that pi over 26 to be multiplied in. Now, what happens to 37,500? Well, that's a constant, and constants disappear. So here I will end up with r dash t, so the first derivative. I'm going to tidy all of this up. So I'm going to multiply this number by the minus by this number here. And it tidies up to minus 11,250 pi all over 13. And then I still have my sine of pi over 26t. that whole thing is its own piece and it can't be affected. So just be really careful not to try and multiply the pi over 26t by the pi over 26 or anything silly like that. When we have sine of an angle, that is sine of the angle and that's closed. If you want to multiply that by anything, it ends up as a coefficient in front. It cannot affect the angle. So part D then says use calculus to show that the revenue is increasing 30 weeks after the beginning of July. So how we show that a function is increasing is we sub in this case 30 instead of t, into our derivative function. So this is our derivative function here. We're going to do or dash of 30, which is minus 11,250 pi over 13 sine of pi over 26 by 30. Putting that into my calculator, I get 1263.44. How this tells me it's increasing is that that derivative is greater than 0. Therefore, a function is increasing. If it was negative, the function would be decreasing. Now, remember what the derivative actually means. It is a way to get slope. So what we're saying is the slope is positive, so that means it's going up, it's increasing. If the slope was negative, it was decreasing. If the slope is 0, means it's turning from a positive to a negative, so we're at what we would call the turning point of a function. Very straightforward, but you have to understand how to work with this. So understanding all about your first and second derivatives, when to use them, it is critical for not just questions that are on polynomials, but like you can see here when we have trigonometric functions as well. So last part of this question says find a value for t within the first 52 weeks when the revenue is at a minimum. Use or double dash of t, so the second derivative of the revenue function, to verify your answer. So what we're going to do is we're going to take again this first derivative that we had, and we want to find where it's a minimum, so we let that equal 0. So we get minus 11,250 pi over 13 sine of pi over 26t, and we let that equal 0. Now, first thing I'm going to do is get rid of that fraction and that coefficient. And when I get rid of that by multiplying across by 13, I still get 0. And then I divide by my coefficient, I still get 0. So I end up with, well, sine of pi over 26t equals 0. So we just want to find a value of t. So you can work this like a unit circle question, absolutely. But because it's 0, there's only 2 times when sine of 0 is 0. So sine of x equals 0. Either x is 0 or x is 180 degrees. So basically what that's telling us is pi over 26t will either be a 0, which gives us t equals 0, which is not very helpful at all, or pi over 26t is equal to pi, so 180 degrees. Multiply both sides by 26, so pi t is equal to 26 pi. Cancel the pi's of both sides, and we get t equals 26 weeks, which kind of makes sense because of the question that we're working with, so half of 52 and so on. So if we looked at, we haven't been asked this, but if we looked at the period of this function, it would be a year, so it's working each year. So halfway through that year is where we hit the minimum. Now, all I've done is let that equal to 0, which is the same method for both minimum and maximum. So what they want us to do is they want us to use the second derivative to double check that that answer truly is a minimum. So let's do that now. So we have t equals 26 weeks, and we want to take our first derivative and we want to differentiate again to get our second derivative. So here is our log tables. We're working with sine this time. Sine differentiates to cos of x, but we're still going to have that chain rule happening. So the second derivative of the revenue function is, again, we leave this coefficient alone, we don't touch it. Sine goes to simply cos, the angle stays the same, but then we multiply it by the derivative of the inner function, which is really the coefficient of the angle in this case. You don't need to tidy this up, but let's do it just to make it look a bit nicer. So I'm multiplying these two pieces together. Again, remember the cos of the angle, that angle piece cannot change. It does not change. It is stuck as it is. So any multiplication will happen in front of the cos function. So when we do this, we end up with minus 5,625 pi squared over 169 cos of pi over 26t. Now you want to sub in 26 into this, and when you do, you end up with 328.5, which is greater than 0, therefore it is a minimum value. So remember, greater than 0 gives you a minimum. If it was less than 0, it would be a maximum. And if it was equal to 0, we would have a point of inflection.